So let's start. So now in this video, we would look at the capacity of the channel when both the transmitter and the receiver have the channel side information. So the system model would be quite similar, but there would be a little difference. So we have this W, which is the message that is to be transmitted from the transmitter to the receiver. And we would have an encoder that would encode the information. But now, since the transmitter side has the channel side information, there is a room for adaptation. So we can adapt either the rate or the power at which the signal is being transmitted. The signal would be transmitted into the channel where it would get multiplied with channel gain, that is root G sub I. White Gaussian noise would be added. And at the receiver end, there would be a decoder, like always, which would take help from the channel estimate. Root G hat sub I, and it would try to decode what was transmitted. Let's call it W hat. And now this channel estimate would also be fed back to the transmitter, and the transmitter may adapt its rate or power so that we can get a better capacity. So now look at under this system model, what would happen to the channel capacity. So now let's talk about the variable rate transmission strategy. So in a variable rate transmission strategy, you would think of the channel having different state. So if P of gamma I is the probability that the channel is in the state gamma I, then the total capacity C would can be written as summation I, the capacity for the state gamma I, that would be B log base 2 of 1 plus gamma sub I times the probability that the channel is in the state gamma I. Please note now this capacity equation can be thought of as you are maintaining a rate B log base 2 of 1 plus gamma I for when the channel is in the state gamma I. This is gamma, or in the continuous domain, you can write this as C is equals to integral B log base 2 of 1 plus gamma P gamma of gamma T gamma, which is very similar to the ergodic capacity equation we got in the first place when we only had the receiver CSI. So we have the same equation, but with a different interpretations. So in the case of the receiver CSI only, the receiver make use of a code that has information about all the channel states, that it incorporated all the possible channel state. It might have increased the latency or the delay in the system, but here you get the same capacity, which can be thought of maintaining a rate B log base 2 of 1 plus gamma when the channel is in the state gamma. And we get the same equation, integral from 0 to infinity B log base 2 of 1 plus gamma P gamma of gamma D gamma, which is not different from what we got in when we had RxCSI only. The reason here is that we don't have used any power control yet. So there is no power control Still, and when we would use power control, we may get a capacity which is slightly better than this capacity. So in the next video, we would see the capacity of the transmission and TX and RX CSI when we carry out the power control as well.